and innovation in production development, leading the development of disruptive production concepts and the integration of technology portfolio, as well as implementation strategy of large technology projects. In his career, he coordinates on-board GLT research project still at Sampis, and he is author of Petrobras patent for the high SAP technology. Thank you, Passarelli, to be here with us also today. And we will have a technical session, and I would like to invite Rune to start your presentation. Rune, you have 20 minutes for your technical presentation, and after that, we will proceed with the presentation of Fabio Passarelli. Thank you so much. Rune,
thank you. Can you hear me?
Yes, Rune.
That's good. Then I'm going to start off the presentation. It's good to be here in Brazil, even though I'm not in a physical shape there. Good to join you guys, and very happy to be able to talk about energy transition and the things that Aker Solutions are doing in that area, especially on the subsea side, which is my main focus, of course. Let me know, do you see the slideshow? When you see the slideshow, please give me a nod, Paulo. That'd be good.
You can share your screen, Rune, that you'll be presented here.
Yeah, I've shared it now. You can see the screen, I hope?
Not yet.
It says I'm sharing. But, can you see it now?
Yes, it's coming.
Yeah. Hopefully you have the Aker Solutions Energy Transition Low Carbon Solution front slide. Is it there?
Yes.
Good. Okay. My name is Rune. I actually find that Paulo is good to pronounce my last name. It's Vesterkjæ. Not too easy for people outside Norway to spell that name, but I'm heading up the Subsea Energy Transition and Low Carbon Solution in Subsea. And I'm going to talk a little bit about Aker Solutions' standpoint and what we are doing in that area. First off, I want to start off with the purpose of Aker Solutions. We have a strong purpose, I think, solving global energy challenges for future generations. And that means, as Paulo was talking about, also this CO2 footprint we put, right? And I think understanding what it takes and what we can do, basically, in that area to help the world is important. And that's something Aker Solutions takes really seriously. We have put up quite some ambitious energy transition targets for the company. It's been said that renewables and low carbon is going to become our biggest business in 2030. And 1/3 of the revenues by 25, 2/3 by 2030 will be within renewables and low carbon. And also internally, we're doing a lot with our internal work. We have a strong focus on ESG, which is environmental, social, and governmental requirements. And we are trying to reduce emissions in our operations by 50% by 2030 and be net zero by 2050. Quite ambitious. When it comes to the renewables and low carbon solutions that we offer from the broader Aker Solution, it's been focusing a lot on the subsea solutions where we have the natural gas naturally with subsea compression, also now trying to aim at the high SEP solutions that Fabio probably will say a little bit about later. We're also focusing on energy optimizations. How can we do the right things in the right place? That's a strong focus, especially when you come to the modification projects and things we do on top sides, but also in the new field developments. Electrification has been one key thing that we've been focusing for many years now, trying to make the electrical Christmas trees that you talked about, but also electrification of offshore assets from shore, so sending power from shore and having solutions in that regard to that. We are focusing on selecting the low carbon concepts on the top sides and also on the seabed. And we are entering more and more into the renewables. So trying to work with the subsea equipment for that, but also topside and floaters and jackets for collector stations for offshore wind. Agricultural is another element we have tried to move into, making offshore fish farms using the technology we have matured for many years in the company, and we see that we're quite we have good solutions for that and can make quite big aquaculture solutions. CO2 storage is something I'll touch upon a little bit in my presentation later too, but it's been a focus to find out where can we dump the waste. Northern Lights is a project I'm going to talk a little bit about, but the focus has been on finding the right solutions in order to ensure that we take away the CO2 from the atmosphere and put it down in the ground where it belongs. Firstly, in order to understand how we can do stuff and how we can work and have a sincere message in regards to that, it's been important for us to set up a clear definition on how we understand low carbon to be. And what we've seen in studies we've done and master theses we've supported and such, we see that the CO2 emissions that are related to power consumption of some equipment is the main contribution when it comes to CO2 emissions. We have also discovered that the activities related to manning, or basically getting people out and in again from platforms, also the supply and the logistics required there to the platforms, has a lot of CO2 emissions to it. Thirdly, we look into the production of steel, basically. So if you're able to make things that are smarter and smaller, like we often do in the subsea area, we can reduce the emissions by having less material use and less material handling as such. Another element, which is a bit difficult to quantify, is actually what we are able to do through digitalization. Digitalization has been a very important focus area from Aker Solutions for a long time. We are able to remove activities such as prototype testing and such by doing things in the virtual space. We have a lot of focus on doing CFD, meaning computational fluid dynamics. So we do calculations and such in a computer program in order to do sizing and verification of our systems. That applies particularly into the subsea compression area, where we are world leading. There we are actually sizing. We're building now a large subsea compression plant for Australia. Everything there is virtually sized and verified. We do not do full-size testing of the equipment. Another thing is to try to avoid testing when things are in operation. We have, of course, in the nature of a subsea solution, you have a remote inspection and testing possibility. And we can also use the models we have established during engineering to do testing and verify how a system will behave, such that we don't have to do that offshore. So all in all, these are things that talk very positively for the subsea environment, where we are trying to be compact and trying to reduce the need for interventions and logistics around it. So what are the subsea low-carbon solutions that we have to offer? One very important thing is the field development knowledge and the field development early phase work that we do, trying to help out our customers in finding optimum solutions with a low-carbon focus for the seabed development. So introducing things like subsea processing equipment, trying to de-bottleneck what's going on the top side is very important to us. Another thing is the digitalization. I talked about that earlier, but you also subsea compression, low carbon solution compared to what you have if you should have a topside solution or onshore compression solution. Subsea pumping could be a good alternative, for instance, to gas lift. Also very efficient transportation, getting closer to the well. CO2 transport and storage, because we get rid of the CO2, we can inject it into the sea, or into the seabed, I mean, sorry. Subsea carbon capture is the next step of things we're trying to do. We're trying to capture the CO2 in the natural gas on the seabed and re-inject that. We have a lot of conceptual projects that we are working on this solution on. Electrification and sustainable power solutions has actually had a good birth, I would say, or youth in the subsea compression area, where you have been supplying power to the compressors and pumps for a long time. Now we're using that qualified equipment and our knowledge in that area to come in with solutions for wind collectors on the seabed. It could be also from tidal power generation and such, and also into the electrification supply from shore, so power from shore and out to the different stations. I've also put in a point of a subsea emerging technologies, so things we're doing because we know a lot about our equipment and know a lot about the behavior of the fluids and the power systems and everything. We've looked into using wind power for gas compression and injection, so basically having wind parks powering a solution on the seabed. We also have SUS, which I'll get very detailed into in a moment. So just to understand why subsea compression is a smart thing and a low carbon thing. It's very energy efficient. So remembering that the most CO2 emissions is related to use of energy. So getting it from the energy mix, whether it's from shore with a mix of different power sources, or as it normally is, being burning gas on a platform in order to generate that power. Going subsea, you could save 60% of the energy doing the same job as you do on the topside. So having compression topside versus subsea. Another beauty is actually that it's an unmanned operation and we have very stable conditions at the seabed. So we're doing a lot with subsea compression in order to help out the world actually replacing coal in the energy mix. Subsea compression stations would be a good solution in order to supply gas into tops or to onshore gas generators, like we do for the Jansz project in Australia at the moment. It's field-proven technology and it's ready for global implementation. And the systems we can make that can vary from small fields to giant gas fields that we are now in delivery on. When it comes to the renewables and the electrification side, the subsea power collector is an excellent example on how subsea is actually the place to be when you want to make a good infrastructure. Looking at the alternative to a floating platform with a power collector collecting the power coming from the wind farm, we're able to reduce actually the capex quite a lot. Another curiosity is actually that the equipment in a substation on the seabed has a higher qualification level or TRL level compared to the floating solution. And here we are using the proving building blocks we have from oil and gas or from subsea compression especially. And this is now ready for industrialization. Northern Lights is what it's a project up in North Norway where we are actually injecting CO2 for storage. So CO2 that has been collected from a capture plant and transported out to the field is permanently stored via the infrastructure we are supplying on that. And this is the first of many carbon capture storage projects that will come. We have delivered now hardware for 2 injection wells, and Equinor has a sustainability plan that shows they will actually extend this number of wells up to 60 wells by 2030. And we're also talking to other players like Vår and Vår Energy and Wintershall, who also have similar goals of getting into the CO2 storage industry. Now I'm going to move over to something that we have been working quite a lot with in the later years. We see that the world is in a dual energy challenge where we need affordable, reliable energy and of course with the reduced environmental impact, or the least environmental impact we can get. And in order to help out on this area, we have come up with this disruptive solution that we call SUS. That's actually building on the decades we have of the experience from oil and gas, in particular subsea compression and power distribution, where we are actually packaging a full-on oxy-fuel power plant for the seabed. By doing this on the seabed and containing the gas, both in the burning process and also for the injection of the CO2, where we get CO2 generated, we have a fully emission-free power plant with instant carbon capture on the seabed. It is 100% carbon capture. Another thing that is good with SUS is that it's also complementing the intermittent renewable energy sources that we have, like the wind parks, as I talked about earlier. With SUS, we have a dispatchable energy available such that we can produce power all the time, whether the wind is blowing or not. So you can use that in a mix together with the renewable energy and have a good, stable energy supply. So our goal with the SUS is actually to make natural gas sustainable. We talked about the emission-free power generation. We also have another beautiful thing with SUS. We use the gas as it comes up from the well and inject the carbon or the CO2 directly on the site. We don't have to do the transportation for thousands of kilometers or do any pre-processing of the gas coming from the reservoir. We can burn what we get. Up to 70% CO2 could also be in the gas mix going into SUS. In that way, we're able to valorize the stranded gas that are located all over the place in the world. This could also be good in areas not only for oil and gas powering, but also supplying power directly to shore, powering up a city or whatever need you would have in the area. I'm now going to show you a video of SUS, so sit back and enjoy.
Video, Rune, I don't know if you have shared the audio also of the video.
So you don't get the audio?
Yes, we have to share the video and the audio also.
So it's okay, that's not good. Let's see now. But audio should be shared?
Yes.
Check if the audio is relevant or not.
You have to increase the audio on your computer.
Should be full on.
No, it's not working.
Is it working now?
No, there's not working the audio, Rune. But
okay.
I believe that is just music, and we can pass.
No, it's a voiceover, but I can try to be simultaneously telling what the voice is.
Yes, okay.
Okay.
Thank you.
Yeah. Aker Solutions' legacy in low carbon technology dates back 40 years. In 1985, subsea processing was born as a simple mapping sketch. Since then, low emission subsea projects have been delivered all over the world. This includes Aker, the world's first and only operational subsea compression station, delivered in 2015. Gas from Aker is part of a low emission energy transition away from coal. We want to accelerate this transition by going to zero emissions. Aker Solutions' patented high-pressure oxy-fuel gas-to-wire technology incorporated in SUS converts gas into electricity close to the well. The CO2 in the exhaust is condensed and immediately ejected back into the ground. making SUS a zero-emission power plant, delivering reliable, stable, and affordable electricity to a world with ever-increasing energy demand. The injected CO2 prolongs production of existing fields and is permanently stored when the field is shut down, never being introduced into the planet's atmosphere. By only requiring a cable to shore, SUS enables production of gas otherwise not economical. Doing so without emissions makes SUS insensitive to carbon taxes or restrictions of gas imports. It makes it not only an environmentally sustainable solution, but also economically attractive. SUS produces reliable, stable, and affordable electricity from natural gas with instant carbon capture and zero emissions. Aker Solutions, we solve global energy challenges for future generations.
Perfect, Rune. Who knows, make it online.
I hope you heard my voice. I did the best I could. So, but I'm going to talk a little bit about the simplicity of SUS as well, because why is it smart to put this on the seabed? I think that's important to know. What I put up here is a density temperature diagram showing temperature density, how the CO2 would behave. So basically a phase envelope, if you like. You can see the pressure lines. By being close to the reservoir, we can have a high pressure between 50 and 80 bar. Being in the ambient seawater, we are able to adjust the temperature on the CO2 such that we get up in what we call a pumpable region. So basically condensing the CO2, if you like. And in this pumpable territory, we're able to inject the CO2 together with the water into the seabed with less power needed, because you can use a pump like Passarella will talk a little bit about later, I hope. So why are we able to do this? I think it's important to look at history sometimes. We've been working with this since '85, as we said in the video as well. We have been working constantly focusing on multiphase and seeing the behavior of multiphase. We've obtained a lot of knowledge in the qualification projects we've done so far, and also the success of the operation of Oscar. So now we believe we are the right company to take this to the market. And we do that with mainly mature and qualified technology, which is TRL7. We have, of course, some components that we need to do extra qualification work for, but that is why we think we could succeed with this. Also together with the beauty of simplicity in the innovation. Thank you very much. That was actually what I was planning to say today. So thank you so much for listening.
We thank you so much for the presentation, Rune, and nice explanations. Now, I would like to pass the floor to Fabio Passarelli. Fabio Passarelli, thank you so much to be here with us today. The floor is yours.
Okay, so I hope you can hear me.
Yes.
So now I'm gonna show my screen. Can you see my screen?
It's coming.
Let me know when it's there.
Yes, we have your screen now, right now.
Okay, good morning, good afternoon, everyone. Thanks a lot for the invitation to be here. I'd like to especially thank Aker, Paulo, Chiquito, and his team for the invitation. It's a pleasure to be here to talk with you about this very important topic that's definitely in the agenda of the oil and gas industry of now and in the future. So I'm Fabio Passarelli. Let's move on. So I'd like to start showing this graphic. Here you have historical data with the oil prices over more than last 100 years. It's important to mention that, as we can see, the oil prices changes significantly over the time. So it's a cycle behavior. Sometimes we have a price very high, sometimes we have a price low. and it was not different in the last years. Today, we see the Brent around $96 per barrel. But if you look at the trend, the mid of COVID, it was less than $20. So one certainty that I have, and I'm sure that everybody has here around this audience, is the price of the oil is cycle. So sometimes it's going to be high, sometimes it's going to be low. We have to be prepared for that, because anyway, the demand for energy of our society will always increase, it will always to grow. So there are some key phrases that we saw when we was in the COVID pandemic, the pandemic time, like finding precedent for unprecedented times, adapting to lower for longer, short-term uncertainty undermining long-term energy investments. Companies balance the short and long-term priorities in the face of low oil prices and the energy transitions. So, as I just say, the decarbonization agenda, of course. So, as I just said, the longer term demand for energy will always like to grow. And the companies will need to have agility and flexibility to build this new capacity to provide this energy to the society, remaining competitive. So in this context, we have gas, oil, and renewables will play an important role in the first future, and connected to that, decarbonization issue, decarbonization agenda, decarbonization issue will be straight linked, straight connected to all the actions from now on. So I'd like now I'm going to put some important tools and some challenge that you have. So in this context, to reach this close future that is being drawn in front of us, we have to accelerate the digitalization. But as I always say, not consider the digitalization as a fancy way to do things, but taking the digitalization as a tool to create value. It has a lot to provide, a lot to offer when you talk about increasing integrity, reliability and availability, operational efficiency, safety, all together go in the direction to reduce costs. It's important to mention that it's directly linked to decarbonization as well, because when you increase your reliability in operational efficiency, in almost 100% of the case, you reduce your emissions. You do better. You do better reducing emissions. The decarbonization topic itself, as I said, it's in our agenda. We have to face this challenge, and you have to rock and roll with that. But what's one challenge that we have today, the oil and gas industry has today? High costs. In general, I'm not saying that in 100 of the cases, but in the majority of the cases, decarbonize imply and adding costs, erode some NPV. So one challenge that you have is how to get this future where decarbonized operation will be mandatory, but with controlled costs. How to make feasible process and solution to reduce the carbon footprint with competitive costs. This is one question and one challenge that all of us together, the academia, the industry, the oil and gas industry, are working together since the last times to reach this goal, to achieve this target. Another topic that it's a hot topic. Solution subsea, as was very well mentioned by Rune. Subsea solutions, subsea electrification, subsea processing like HISEP, like subsea compression, like subsea water injection, they definitely provide the opportunity of reducing emissions. They can improve efficiency. They can do the same using 56% of the total power that you would use for a topside solution. So we see in this next future huge opportunity for subsea processing, long tiebacks, subsea solutions anyway. Each includes power generation. One of the big challenges today, how to make everything that we said up to now move into the subsea direction, but always there is one big and very important topic to provide power to run the process. So coupled to that, power, subsea power generation or solutions for power generation, as we are going to see in some of my next slides, they are crucial, they are key in order we reach this future vision very well, very like and very necessary. When you talk about wind, it's a fact that the industry, the world, progressed a lot to the wind. I'm here. I work in a Brazilian company. It's important to say that in Brazil and in some of many other parts in the world, we have a very high capacity factor when you consider wind. In south of Brazil, this capacity factor is very high, closer to 40%. And when you go up to the northwest part of Brazil, we see capacity factors around 60%, which is very high. The industry progressed a lot in wind generation systems, mainly for onshore. Now we can clearly see that it's moving to shallow waters, but we have to start thinking how to pave the way to get the wind coupled to oil and gas production in ultra deep water as well. So it's a clear scenario that we always reevaluate. Today, cost is I would say is a barrier. Besides some technological, but cost is the biggest barrier. I'm sure that with innovation and partnership, consider the academia, considering the industry, and consider the oil and gas companies, we will be able to develop innovative solutions to drop down costs and make feasible. Because definitely the renewable power that will come from wind will play an important role in this decarbonization world, this decarbonized world that you have to see in the next year, in the close next years. My last one about this general overview is about solar. How is going to be the solar generation after 2030? This is the big question because today, what you see, it's a very important source of power. For example, in Brazil, in many other countries, we have plenty availability, but we see high cost and low density of power. The challenge is how to increase the density of power of solar in order we can connect with success this very important renewable source, no carbon renewable source, to the oil and gas industry. How to make it feasible, how to make it fly. This is one of the questions and targets that we need to have. Now, coupled to the wind that I mentioned, the solar, we have other source like from tiled waves and so on, including maybe subsea or topside nuclear. So my main message is power generation, and you're going to see in the close slide, power generation is key. Today, in the oil and gas industry, the power generation is responsible to about 70% of the emissions in a typical oil and gas production facility. So the way that you produce power will be key to this decarbonized world that you are pursuing, that you need to have in the close years. So only to state this public, in the Petrobras site, we can see, I'm bringing the example of our company. Our priority is to operate with low costs, with superior performance in carbon, protecting competitiveness of our products in a low carbon world. When you look to the three pillars, we see transparency in carbon quantified in critical process, as we call the double resilience in fossil, because during this transition, the fossil is still having an important play as power supplier of our society, together with this low carbon agenda. and electrons strengthening the skill to create value in low carbon. So there always is a balance, keeping low costs, but with the agenda of low carbon, achieving these both commitments, and because of it, this is one important invitation to the academic industry and so on to join in for big, start slow, but think big to reach the challenge. When you take the example of low carbon solutions in a upstream facility, we can classify in short terms and medium long term ones. For example, a short term, existing assets. One important thing for any oil and gas industry company, take into consideration that when we have this agenda for reduction of carbon, but we have many assets arranged under operation, is operating well what you have. This is very important. So improving efficiency, operating well what we already have, it's very important because it plays an important role in the carbon footprint reduction of the operation. Besides of it, always we have to pursue improvement of energy efficiency, and of course, the digital transformation may help a lot on it. Focusing on technologies and solutions to reducing losses, including flaring, venting, fugitive emissions. Efficiency of maritime logistics. We know that the fuel that we use for the logistics, they have impact in the emission. So starting change this fuel, popping to going to the direction of low carbon fuels or net carbon zero emission fuels, and optimizing the logistics itself and making it smarter, can provide many excellent results. And the digital transformation as a topic is a material topic that definitely can help, may help many disciplines and many areas of our oil and gas industry chain. As medium and long term, we can consider new projects. New projects, of course, the industry will have. New projects, they may be conceived, they may born with low carbon solutions, including solutions that are more optimized, like a combined cycle, full electric, or even the ones that may add some carbon capture system. And these new projects may come with innovative power generation systems with low carbon, or even include a huge partial of renewables, which is very like. Okay, so these are it's a trend. New projects within this background, electrification that may include electrified solution, electrification, combined cycle, zero routine, carbon capture, utilization, storage, and so on. This is a kind of carbon mitigation roadmap. When you look to the field approach, so we can list some solutions that we just listed, like all electric combined cycle, subsea processing, as it's a recap what we have discussed today. Subsea processing, including gas compression, high subsea water and oil separation, water injection, and so on. Improve efficiency, any kind of action to improve efficiency, energy efficiency, carbon capture, and other. Again, when you look at typical offshore GHG emissions, we have energy for energy production, losses, as you can see, energy production, losses. And when you deep dive the turbines, that the main way that you produce power today in the oil and gas offshore facilities, they are in charge of 70% of the total emissions. So again, and as I said at the beginning of the presentation, focus our attention in the way that you produce and distribute this power. It's going to be key in this low carbon world that we will see in the close future. So we can mention some ideas, some possible technical solutions like power hub, power from shore, flow to wind, and others. Like, for example, the one that was mentioned by Rune, the Zeus technology that's patented by Aker. It's one example that a solution that can be itself since its concept, from this concept, zero carbon emission. Definitely, this is one very important trend that you have to concentrate effort to put in practice innovative solutions. So as a sum, I'd like to highlight what I got from the DNV Oil and Gas Forecast 2050. Three main informations and drivers. So gas will continue to play a role along together with renewable, because the low carbon world is a reality. So gas improve the access, and the way that use gas definitely will increase, because gas help on the carbon, gas as a fuel help on the carbon emission, but together with renewable to reach this target. Digitalization and automation definitely will have a significant contribution. It talks with unmanaged facilities and improve the operation to do what we do today better in best operational efficiency points and so on. And the last topic is about cost and control. Cost control remains key together with innovation, because we are talking about many new solutions that may, in the initial view, may add cost to the final solution. And of course, after deployment, after studying better with innovation, definitely massive use, definitely, I'm sure that the society, the industry will find a way to optimize the solutions and reach more optimized and low-cost solutions. What I thought interesting from GTV, that all the technical aspects were emphasized, but we cannot forget that operational modules in contract strategy we have to be thought together, because the challenge is not only technical. Maybe you have to develop new business modules, operating modules, the way that maybe one company may produce the power and sell this renewable power to the oil and gas industry. So it's like the operationing or business module and contract strategy. They will be very important to pave to support the success that I'm sure that the oil and gas industry will have in the next year. So I'd like to finalize my presentation with one tenth from Theodore Levitch that in my opinion is very linked to what the ambitions that all of us we have for the next year, for the coming year. What's often lacking is not creativity. There are many ideas, but in the sense of creating ideas, but innovation in the sense of putting the ideas to work. Let's make it concrete. Let's transform the very good ideas in skill. Thank you so much.
Thank you so much, Passarelli, with this, including this final message. We have to put the ideas in practice and have the value implemented. Amazing. Well, we already have a lot of questions from our audience here. And Leandro, do you want to start?
Oh yes, Paulo, I can start. So the first question from the audience was to Rune, to be addressed to Rune, related to Zeus. Rune, what's the technology maturity level of the Zeus now, and when do you believe it will become, let's say, live?
Yeah, you have different components in Zeus, right? So it's unfair to give Zeus a general technology readiness level, I would say. But if you look to what is new here and what we're wondering about, it's really the packaging on the seabed of the oxy-fuel burner, which we would say would have a TOL2. But a lot of the equipment in the Zeus solution, including pumps and vessels and such, are already TRL7. In order to get to the market, of course, there is some road ahead of us, that's for sure. We are discussing and planning a prototype testing at the moment. that will maybe be executed in the nearest years, I would say. Our aim internally is to have this ready early in 2030, 31, 32. We don't know exactly on the seabed.
Okay, thank you, Rune. We have another question, maybe you, Rune, and Passarelli. This question is for both, and I would like to see your view about that. What are the impacts in maintenance hours and people on board numbers when you use the subsea technologies instead of doing it on the platforms? Both of you have talked that we decrease the amount of energy and also that's related to costs and so on, but here is mainly focused on maintenance hours and people on board numbers.
Okay, very good idea. First of all, we do believe that a combination of topside solution combined with subsea solutions, not in a competitive way, but as a complementary way, like the extended plant, may have global capex, global investments in reduction. When you talk about carbon and power consumption, as we said, it may consume 60% of the solution from topside. When you talk about maintenance, definitely we hope to have as well a reduction in maintenance in topside. But it's a fact as well that the subsea OPEX over the years, we expect to be increased because making maintenance in subsea solutions is more expensive than making topside. But when you look the entire project, consider CAPEX, OPEX, and ABEX, we see opportunity to have better results when you combine the solutions. The overall package, the overall result is going to be better, despite the increase in OPEX costs.
If I may add also, I agree with Passarelli here in regards to topside and subsea solutions combined is often the selection you do on the field development. However, looking into the maintenance part of subsea, we have tried to make the system kind of inherently maintenance free, if you like. So focusing on robustness, redundancy is the main elements when you go to the seabed with equipment. If you take the pumps for an example, we have punished them well, is what I would say, during testing and in the material selections in order to not do maintenance. If you look at the compressor solution, comparing it with the topside solution where you have lube oil systems and all this complex system, the subsea compression solution is a hermetically sealed one unit, right? We have magnetic bearings, so the shaft in the compressor is hoovering basically, so you don't have that much touching. The friction is not there, if you like. So this design focus on robustness and reliability is really limiting the need for maintenance. If you look to Oscar subsea If you look to Oscar subsea compression, we planned for some maintenance by having modules replaced, right? So the full module replaced in order to reduce the downtime. There was a plan for a lot of offshore campaigning on that. That has not happened because the design has been inherently good, such that it hasn't failed.
Yeah, I would add only to support the Rune words as a end user. In general, it's true. In general, the subsea solutions, they have a much higher reliability. That's true. And since the concept, since the design, the subsea engineering companies are very concerned about it, how to provide more robust and reliable solutions. So it compensates a lot, this need for maintenance compared with topside. Experience. We had already subsea pumps that run more than 7 years without any type of maintenance, without stopping. So it's an unbelievable information, unbelievable time.
Thank you. Okay. So next question now will be, we'll go to Passarelli regarding carbon capture. So you mentioned, Fabio, in your slide that there is a possibility to have carbon capture in the future in some of the new plants or FPSOs, as I understood. So what are the real plans for Petrobras in this topic, for example? Do you believe that we will have something similar what we have in the Northern Lights project, as Rune mentioned here in Brazil?
Yeah, it's under evaluation. This carbon capture technology route, we have application already onshore. It's still under evaluation for offshore application. Some, let's say, de-risking activities are necessary to reach there, but definitely it's on the agenda, on the plans to always evaluate this application, check if it will generate value together with our ambitions for carbon reduction. And again, some technical de-risking activities are necessary to reach there. We do believe that it's going to be possible.
Okay, thank you.
To make the solution available for use.
I have another question for both Rune and Passarelli. When Rune explained the overview about what is low carbon solutions in Aker, and also Passarelli has shown the short-term solutions that has been applied in the Petrobras, and other operators are using the same strategy. But I would like to hear from you if we are going fast or slow regarding our global goals that we have for 2050. Who wants to start? Rune,
can you? Well, the global goals for 2050, it really requires governmental involvement, I would say, just to be honest, because that's what we've seen as one of the hurdles in getting into these low carbon solutions and having that as the selected solution, right? It's been a history in the oil and gas industry that we focus a lot on, or the operators focus a lot on making the optimized solution using qualified and field-proven technology, right? That is a challenge. Also that the natural gas, for instance, is available on the fields, so it's easy to burn that because that's for free, if you like, to burn that in the power generators on the top sites, right? In Europe now, it's a lot of focus on carbon taxes and the carbon quotas, right? Where you have to pay extra to emit extra, right? When you get that into the equation, it's turning out to be a better business case in a lot of areas, because then it starts to matter how much power you consume. So if you can save 50% power or something on going subsea compared to topsides, you can maybe justify that only with a carbon tax saving over the lifetime. But I think these measures have to be in place in the beginning in order to be able to be successful in trying to reach that goal that we have. And that's just me trying to be a bit realistic on it, because it's difficult to change if you don't have good incentives.
Yeah, that's true. We saw in the world already some carbon capture projects that they are very successful, but they had a very intensive incentive from governmental authorities. And I would like to point that definitely we are in an energy transition phase. If it's going to be fast, medium, or fast, it depends of many different inputs, not only technical, not only technological. What you see that the oil and gas companies, they always work with scenarios, if it's going to be slow, medium, or fast. And the main message that all of us have to be prepared to any route and being capable to very fast correct the direction if necessary, in order to reach and to move forward as this energy transition will dictate that the pace in the next year. To summarize, there is no definite answer. In my opinion, we have to still monitor it, being prepared. Decisions methodology to be very resilient and fast in the decision taken required time.
Okay. We
Hello?
know.
Can you hear me?
Yes, yes, we can hear Passarelli. We have just delayed here, but now it's okay. Thank you so much for your thoughts and comments around that. And we are reaching the time right now, Leandro, but it was an amazing discussion here and very nice presentations. Appreciate so much.
Yes, I'd like to thank you, Rune, and also Fabio for the present here, and also to share all your experience with us. And also I'd like to thank everybody that's here with us presentially in São José, in Curitiba, and also the ones that are connected online. So there were many other questions that were not answered today, but we will be answering in the backstage and sent to you by other Aker Solutions channels. Okay? Thank you very much.
Thank you.
Thank you.